All right, so we've learned how to create non-dimensional equations in two ways essentially so far. One is you could just be told them by me or look them up in your book. That's fine. One is you can non-dimensionalize an equation and see what falls out, and you'll get dimensionless groups. All right, the third way is to do what's called the Buckingham PI theorem. Now, the Buckingham PI theorem is a super sort of algorithmic way to create dimensionless groups, which in the Buckingham PI theorem are referred to as pi groups. Okay. So what I'm going to do is write out sort of the steps in general, and they're not going to make a whole lot of sense, but we'll go over it in class and also in the lecture so you understand a little bit better. So the first part of the Buckingham PI theorem is this. If a problem has n, and let's highlight n, all right, variables, dimensional variables. Okay? It can be reduced to k pi groups where k equals n minus j. Okay, and j is the number of independent, all right, dimensions in the group of n variables, okay? And the little caveat, at most, j can be less than that. All right, again, we'll talk about what that means. All right, so that's basically the idea here. So step one, so first is you got to find j. All right. So this is sort of the main idea of the Buckingham PI theorem. I had a one up there, but we're just going to say that's that. So this is the main idea. So when you do the Buckingham PI theorem, it sort of goes through steps. So your first step is step one, you find n variables. All right. How do you do that? We'll talk about it. We'll do problems of it, but essentially you're just going to choose variables you think are important to the problem. All right. Then two, all right, you're going to create a chart, and I'll show you the chart in a second. All right. Three, you're going to select j repeating variables. Now again, j is equal to the number of dimensions in your problem. Always. It can be less. We'll talk about when it can be less, but almost always it's going to be the number of dimensions in your problem. So if your problem has dimensions of seconds and meters, j is 2. If your problem has dimensions, and it's fundamental dimensions, right? So seconds, meters, kilograms, then j is 3, okay? All right, so you select your j repeating variables, all right, and these j repeating variables are going to be used to find all the other dimensionless parameters. So for you use j variables to create k pi groups. All right, that's the basic idea here. So how do we do this? So let's say you go through a problem and you list out a bunch of variables. So let's say we have some problem, we decide, there's height, there's a length scale that matters, the viscosity of the fluid matters. Let's not do viscosity because you don't know the units of that yet. Let's say, we'll say there's a length, there's a density that matters, there's a force that matters, all right? Let's say there's a velocity that matters, and let's say maybe there's even another length scale that matters. Okay. All right, so now what you're going to do is for each one of these, you're going to list out the dimensions. But first, we're going to do it in such a way that you reduce the dimensions down to the fundamental dimensions. So, what are in MKS or whatever in SI units, the 7 fundamental dimensions are amperes, all right, candela. So amperes obviously measure current. Candela measures light intensity. Kelvin, all right, Kel, which measures temperature. Kilograms, mass, meters, length, seconds, and moles. All right. Those are the 7 fundamental units. All more complicated units can be simplified into some version of these 7. So for instance, we're going to say most of the time in our problems, we're here. Very rarely, sometimes we might add in K. All right, but basically for us, the fundamental units that we're interested in are meters, kilograms, seconds. So the way this works is you're going to make a little chart: kilogram, meters, seconds. Then you're going to list your variables above it: L, rho, F, V, and D. I don't know why I'm doing these dotted. We'll do a nice solid line here. All right. And in each one of these boxes, you're going to write what are the units of that particular variable. So for instance, L we said was a length. It has units of meters. So we put a 1 here. It has nothing in kilograms. It has nothing in seconds. What are the units of densities? They're kilograms, so 1 there, per meters cubed. So the meters cubed is a -3, right? Because it's meters cubed, but on the bottom, so the negative. And they have no units in seconds. What are the units of force? Well, I know you're going to say newtons, but right, that is a kilogram, 1, meter, 1, per second squared, so that per tells us it's on the bottom, minus, I wrote S, but what I mean to write is 2, minus 2. What are the units of velocity? They're meters per second, so 0, 1, minus 1. And there was another dimension, 0, 1, 0. Let me just do this, all right? So, when we talked about N and K before, right? Here was N. N, right there, is our list of variables. J is the number of columns in this matrix. Now, it's always going to be 3 for us, unless the only time J is less than 3 is if I can take one of these rows. Let's say I could take, I'll say row, I have row 1, row 2, and row 3. If I can take row 1 and multiply it by some variable, let's call it I, such that I is an integer that is greater than 0, and I get row 2 or row 3, or I can do that with row 2 or row 3. So if any one of these rows can be multiplied by some integer I, then it doesn't count, all right? And so you really only have, then you would have j minus 1. So if row 1 equaled row 2 times 3, then I would only have j equals 2. But that is such a rarity when you get to a lot of variables that j almost always equals 3. All right? So now we have n is the number of columns in this matrix here, right? J is the number of rows in our matrix, which means that k is equal to n minus j. So in this problem, n is 1, 2, 3, 4, 5, minus j is 3, which means we will create 2 pi groups from this little example, all right? So we make our matrix, right? Then the next step is you pick the repeating variables. All right, there are tricks to this, and the real trick is, what I would suggest doing is picking a variable such that that you pick 3 variables, one that has 1 unit, one that has 2 units, and one that has 3 units. So in this case, we could say, I'll circle them in green, L, rho, and F, right? L has 1 unit, rho has 2 units, F has 3 units. The reason we do that is because we don't want the 3 variables, either one of these, to be able to create a dimensionless group on their own. So if L over rho was dimensionless, this problem won't work well. Okay? So once we've done that, we have our 3 repeating variables. We're going to create 2 pi groups. So pi 1 is going to be L to the alpha, rho to the beta, F to the gamma times V. And pi 2 is going to equal, well, first let's do pi 1. So first we'll solve for pi 1. So how do I do this? If this is supposed to have units, no units, it's supposed to be dimensionless, the trick is then to look across this line and go and create an equation for each row. So for row 1, we have what? Alpha times 0, because L has units of 0 kilograms, plus beta times 1, because there's a 1 in the beta, plus gamma times 1, because there's a 1 in that, plus 0, and that has to equal 0. I can't have any units in kilograms at the end. So this equation tells me that beta must equal minus gamma. Now we do row 2. Row 2 says alpha times 1 minus 3 beta, right, plus gamma plus 1 has to equal 0. So this is a little bit more complicated, all right? We know that beta has to equal minus gamma, so we could say that this is alpha plus 4 gamma, right, plus 1 has to equal 0, all right? And so that gives us an insight, right? We could solve, we'll solve this in a second. And now we go to row 3, and then we say, okay, what do we got here? We say 0 times alpha plus 0 times beta minus 2 gamma minus 1 has to equal 0. All right? So from this equation, what do we find? We find that gamma has to equal minus 1/2. Now we can take that, we plug it into here, and what do we get? Well, we would get that alpha has to equal minus 2 plus 1. Alpha would equal 1. And up here, we know that beta equals gamma minus 2. So from here, we can say that this is 1/2. So now we just plug these in. We know what gamma, beta, and alpha are, and so our dimensionless parameter, pi 1, ends up equaling L to the alpha, which was 1, so L rho to the beta, which was 1/2, times the square root of rho, F to the gamma over the square root of F times V. And if you check, if I've done my math right, this is a dimensionless parameter. Okay? Now we could do the other one. Oh, you know what? No, I'll just leave this here. So pi 1 and the square root of F. So if we go back, I'm trying to find a place to do it. I'm going to do it up here where we get rid of our units. All right. So pi 2 is going to equal, well, and we'll use alpha, beta, and gamma again. So we'll still say L to the alpha, rho to the beta, F to the gamma, and this time D. And we still go row 1. So for kilograms, we still have 0 times alpha plus beta plus gamma. And D has units of 0, right here. So plus 0 has to equal 0. Why does it equal 0? Because we don't want any units when we're done. All right? Now we go down to the meters line. We say alpha minus 3 beta plus gamma plus 1 has to equal 0. Okay, and then we go down to this, the second line, and we say 0 alpha plus 0 kilograms minus 2 gamma has to equal, plus 0 has to equal 0. So from this equation here, we know that gamma equals 0. That means up here, beta equals 0. And here, we'll get that alpha equals minus 1, which means this is D over L. Makes sense. Meters over meters. They're unitless. All right? So, Once you've created your j variables to create your k pi groups, then you solve to make dimensionless. Okay? So this is a confusing process, and there are a lot of choices you have to make, and we will show in class how you make those choices, all right? The basic idea is for any problem, you'll pick a bunch of variables you think are relevant, you'll count the dimensions, you'll make this chart, all right? For the number of j rows in your chart, you'll pick 3 variables on top to repeat. Again, I would follow the 1, 2, 3 rule, one variable with one dimension, a second variable with 2 dimensions, and a third variable with 3 dimensions. And then you'll go through these equations where you're just trying to make the exponents such that the variables all have, when multiplied all together, the dimensions go to 0.